guys, welcome back to Rocket Gyan, my fellow space tubers. So today we have a very cool launch, I should say. Uh, we have a launch of the Ariane Space rocket company, and the rocket itself is Ariane 5. So we should have a look and as in what it has in store for us. So guys, here we are at if you don't know, the Ariane Space is basically has a collaboration with ESA, you can say, and that is their you can say the European Space Agency. If they have a launch company, then the launch facilities are provided by Ariane Space. So that's what it is. And now we can have a look at the rocket itself. So here we have the rocket Ariane 5. It is the heaviest launcher, means the heavy launcher and the heaviest launcher for Ariane 5 right now. And let's just have a quick look at its stages first. So for it, it has two solid rocket boosters attached to it. These are so big, we can't see it right now, but I will, once I'll open the images, then you will see. We have two solid rocket boosters. One okay, let's just have a look at the solid rocket boosters only first. So here you can see this is the size of one single solid rocket booster. It is huge. It is 30 meters tall, and yeah, it provides 90% of the total launcher's thrust, and yeah, that's what it has. So it is a solid rocket booster, means it has to provide a large thrust, but 90% of the total thrust is provided by these two solid rocket boosters only. So yeah, that's what it is. Now we can have a look at the engine itself, the Vulcan 2 engine. See guys, this looks so cool here, right? This Vulcan engine looks so cool. So this Vulcan engine basically is a turbo pump fed engine, and has and is a regenerative cooled engine. So what is regenerative cooling? Regenerative cooling is basically uh, a cooling which is done by the fuel itself, the cryogenic fuel itself. And what part it is cooling? It is cooling basically the you can say the bell nozzle of it. Okay, so that's what it is cooling, because the when the exhaust come out of this, then it becomes hot, right? And it needs to be they cool down, otherwise it will melt. That's why. So yeah, and this engine has the gimbal control. It has a gimbal control, so we have a pitch and yaw control from it. So that's what we have from the Vulcan 2 engine. This is the Vulcan 2 engine, and this is the cryogenic main stage it has. And this engine is powered by, basically run by, you can say, hydrogen and the LOX as the fuel, means the liquid oxygen as the fuel, hydrogen and the liquid oxygen. So yeah, that's what it is. This is the cool second stage of the Ariane 5 rocket. And it is basically, these two stages are only there. If we just remove the solid rocket boosters, we have only these two stages. This is the mostly vacuum optimized thingy, and it is a, yeah, cryogenic upper stage HM7B engine it uses, and it also runs on hydrogen and liquid oxygen as its fuel. So yeah, that's what it is all about. Then we have the vehicle equipment bay. This is basically this bay has all the avionics, you can say, all the safety mechanism and all, means the various flight computers and everything is done, is placed here only. Okay, then the payload adapter, as we all know, this payload adapter is used to stack the payload on it. Basically this payload adapter is used for uh, taking placing the payload on it. And the payload we will be having today are the some of the satellites. I'll discuss about them also. And yeah, this is how it looks like. And then finally the fairing. Okay, so of now we can have the specification also. So the 10, it can take 10 tons payload to geo transfer orbit. Now that's a huge payload, because the normal low earth orbit is, it takes around 20 tons. 20 tons it takes around. So what is geo transfer orbit and what is low earth orbit? Low earth orbit is nothing but you can say as the name specify, low earth orbit around 500-600 kilometer. This is the low Earth orbit range. What is a geotransfer orbit? Geotransfer orbit is an elliptical orbit in which the periapsis touches, you can say, sorry, the apoapsis touches the geosynchronous orbit line, and the periapsis has around 500 to 600, and then that's what we call the geotransfer orbit, because from there the satellite can place itself into a geostationary orbit. Okay, so that's what we have for this. Now we can have a look at the payload and the mission profile, guys. So here we go. We have the payloads. The payloads are Galaxy 30, MEV-2 and BSAT-4b. What are these? I'll just tell you in just a bit. We'll orbit Galaxy 30. This is, here we go. We have Galaxy 30 and MEV-2. What is MEV-2? Galaxy 30 is nothing but a first replacement satellite in Intelsat, so blah blah blah. Basically, it is a communication satellite which provides ultra high definition and over the top network and broadband and all. This is a normal Galaxy 30, means the normal satellite which is provided for the communication. But here with here some twist occurs. MEV-2. This is an interesting payload which is going. So what is MEV? MEV stands for Mission Extension Vehicle, and this, as the name suggests, this is basically used for extending the life of a satellite. So guys, like you can say in geosynchronous orbit, when the fuel of the satellite depletes, then this MEV-2 vehicle, they can just dock with that satellite and provide, you can say, the thrusters or the fuel or the thrust to that satellite so as to place them in a particular orbit. Okay, and it can hence extend the lifetime of that satellites by 15 years. And this MEV-2 is basically can also dock to multiple satellites once it has completed the, you can say, the orbit raising or orbit maintaining maneuver for the one particular satellite. It can undock and then redock with another satellite to provide the same service. So yeah, that's the thing. The next payload, we have the BSAT-4b satellite. This is a backup satellite for the broadcasting satellite system. This provides a direct to home television service. So yeah, but it's a backup satellite. The main satellite was launched in 2017. So why do we launch a backup satellite? We need a backup satellite because if something happens to one satellite, then we can revert our all communication to a backup satellite, as we don't want our customers to you can say complain when we don't have a signal from the DTH. We don't want that, right? So yeah, that's what the thing is. Now guys, I would love to show you one most interesting thing about the MEV. Just wait a sec, guys. And basically it will tell you what we have. Here we go. This video I have, guys, this will tell you what this MEV or the mission extension vehicle, yeah, this is made by Northrop Grumman, a prestigious, you can say, company, aerospace company of America. So this is how everything looks like. So it docks with some another satellite and provides thrusting to provides, you can say, thrust service, or you can say the act as a service module to it. Okay, so yeah, let me just, yes, now you can see it. As you can see right now, MEV-1 circumnavigates and inspects IS-901. So this was basically, this was the main payload. This is one already, MEV-1. Now we have MEV-2. So this is a proven technology, hence, and this is a video of how actually happened, the MEV-1 happened. So we can have a look at it. So right now it is basically trying to have a look at where it should dock, and then it is closing in, it is approaching it from behind, and the docking mechanism itself is very unique because we don't have any docking port on a satellite. it docks on the engine side. Just see what happens right now. The actual photos which you can see right now here, and right now it is approaching this satellite. This is to be docked. Then it is the ground control authorizes to approach the capture box, and then it stops about 1 meter behind IS-901 or reconfiguring its orientation. Now see the docking mechanism itself. See how this claw kind of a thing, first of all something goes inside this engine bell, and then this claw kind of a thing just grabs the satellite. This video will now end here. We didn't get a good info like what happened, so I have another video which will tell us what will happen. So multiple docking and undocking can deliver over 15 years of life extension services to a vehicle. So this is the first docking which happened, and it will see, this is a detailed image. So how it is inserting something into the nozzle of the satellite, the engine satellite's engine, and then it will capture. Yeah, so that's what we had something. So yeah, it is an interesting thing which basically happens. So now guys, we can switch over to the launch itself. It is happening, and yeah, let me just switch to that. Just wait a sec, guys. And here we go. Oops. Okay. Yeah. So this is the stream will start in these many seconds. So guys, that's what the info was all about. So yeah, hi Drexper, hi Stacy, hi Christopher. Uh, Starting the European quality. Okay. Hi Esteban. And so yeah, this Ariane 5 rocket launch itself is very beautiful to see, because all those solid rocket boosters, they ignite beautifully. And uh, if I'm not wrong, right now in the French Guiana Space Center, sorry, it is night time, and we will have a good look at the rocket itself, the ignition and all, so lift off and all, so it will be a good thing to watch, right? And and don't worry guys, I'll explain you each and everything which will happen. So just be with me. And so 10, 9, 8, 7, and we are already 29 minutes from the launch. So now it must.
Hello there. You join us live here for the launch of 3 satellites tonight from the Guiana Space Center, which is in South America. We've got 2 telecommunications satellites waiting on the pad, and also 1 mission extension vehicle. Now, if you're a bit curious to know what that is, then you're in the right place, because we're going to be finding out about the satellites tonight in the next hour. We'll also be watching the launch, of course, and we'll be following their journey through space. We've got lots of experts lined up for you tonight, and one of them is this man, Stefan Israel.
Hello.
Stefan, thanks for joining us. Stefan is the CEO of Arianespace, and which makes you perfectly placed to tell us about what's happening tonight. Stefan, first of all, let's take a look. We can see on our screens the launcher is on the pad, looking pretty good there. We've got a few clouds in the sky, though, tonight, haven't we?
Yes, but the launcher is on the launch pad. It has been transferred yesterday and everything is okay. We are now making the final operations, and as always, we are going to monitor the weather and to check the clouds, yes.
So we've got 3 customers tonight, as we said, and, sorry, 2 customers, but 3 satellites. So tell us about that.
Yes, so tonight we have Intelsat with Galaxy 30, and you know Intelsat is a very long-lasting friend of Arianespace. The first Intelsat satellite was launched in 1983, and tonight we are launching the 62nd satellite for Intelsat. We have another very old friend, which is BSAT, a Japanese operator. This will be the 10th satellite we will launch tonight for BSAT, and our relationship has started in 1997. And we have a newcomer, SpaceLogistics LLC, which is a subsidiary of Northrop Grumman. Northrop Grumman has built MEV-2 and in the Galaxy 30. Maxar has built the satellite of the Japanese operator. And this is a new vehicle tonight because this is a mission extension vehicle for in-orbit servicing. So we are very happy of this innovative mission.
It's exciting, isn't it?
Very exciting.
So we'll be finding out more about it later in the programme. But let's just talk about the situation we're in at the moment. Obviously, it's very complex, launching satellites during a global pandemic.
Yes, for sure. So you know that we are now in the context of a pandemic of the COVID, which is in all South America. And it is clear that this is the case in Guyana. We have taken all health measures to make sure that all our teams, the teams of our partners, of our customers, are working by respecting very strictly the new health conditions. And this is the case tonight in Guyana. And I really want to thank the team for the fact that they have delivered in such a difficult situation.
And of course, our thoughts and our support to everybody
yes.
in French Guiana who's struggling with this right now. Let's just go back to Ariane 5, our launch vehicle, because she's incredibly powerful. You launched several launches from the spaceport. She's the most powerful one, and she's becoming even more powerful, isn't she?
Yes, tonight it is the most powerful Ariane 5 we have ever launched. We have a capability of 10.2 tons for the satellites, and it is due to a program we have made with our parent company and prime contractor ArianeGroup. Since 2016, we have increased by 300 kilos the performance for the satellite by diminishing the mass of the launcher. So tonight it is the most powerful Ariane which will fly.
So it's an
well, that's good to
fact.
know. Well, Stefan normally is with us in French Guiana, heading up a very important group of people called the Flight Directorate. But of course, we're here in Paris, and Stefan, we're lucky to have you with us, actually. But we can go over, let's hope, now to the Guiana Space Center, because tonight Luce Fabregat is there heading up the Flight Directorate. Luce, what is the Flight Directorate?
Hello, Katie. Yes, very pleased to welcome you inside the Mission Center at the flight desk, as you said. There are 4 of us tonight here, and we will have the final say for the go-to launch. With me, Roland Lagier, who is our CTO at Arianespace, the highest technical authority for tonight's launch. Bruno Gérard, who is heading Arianespace teams here in French Guiana, fully connected with local authorities tonight, and on communication aspects with us, Martin Studer.
Okay, so we have a good
tell us about the situation in the Jupiter cell, and how are the things going now for you?
So as you can see, the situation is very smooth for the time being. Everybody in front of its computers. We need, as you know, Stefan, we need 3 components to make a launch: the satellites, and the customers are in front of us, ready to go. We need the launch range, of course, and the downrange stations also under the authority of CNES behind me. ready to go also, and to support us for this launch, and of course the launch vehicle and its ground segment. And today, tonight, everybody is ready to go.
That's good to hear, Luce. I can see, though, that everybody is also being very conscientious about social distancing.
Yes, we have taken, it was a very specific campaign. We have taken very specific measures, distancing. We all wear masks, and that was the way to avoid and to strictly limit the spread of the virus, of course. And it works. It has been working quite well. So today of course we have been during the whole campaign and for a few months, the whole space community has been very supported of all the efforts performed by the people here in French Guiana. And tonight we think about the people here in French Guiana who have been touched by this virus, and we want to tell them Chamberet Pamoli in Creole, you know Katie perfectly. So keep up, don't give up, keep up with all the measures. We need them, and we are convinced that today the Ariane launcher will bring all its power to French Guyanese people.
Luce, thank you very, very much indeed for joining us, and best wishes now for the rest of the launch. Stéphane, you're going to be coming back to us again later, but yes, for now, thank you very much.
Thanks a lot.
Stéphane Israel, ladies and gentlemen. Well, I promised you some experts, and we also have Damien Gilles with us tonight. Damien Gilles is the head of systems engineering. Damien, very briefly, what does that mean?
I'm leading a short team of experienced system engineers who are in charge of mission conception for all the launcher of Arianespace family, and mission design mainly covers trajectory and ballistic phase optimization, as well as demonstrations that the spacecraft can sustain the condition of a launch.
Great. Well, thank you very much indeed for joining us. Let's take a seat. And Damien's going to be with us now for pretty well the rest of the programme. We have been preparing the satellites and the launcher for the last 3 months or so. It's called the launch campaign, started with the assembling the launcher. What happened next?
Galaxy 30 and MEV-2 landed at Guiana Airport end of June. They were transferred then to the payload preparation facility 72 kilometers away. They started there their standalone activities. In parallel, our lower passenger BSAT-4b arrived in Cayenne and followed the same path until the same building, which is S5C, where it also started its standalone activity. You can see there on the images the feed check. Feed check is the operation where we check that we can attach the spacecraft to its nearby structure without any anomaly. After that, the 2 upper passengers were transferred to the hazardous payload processing facility, where they will be filled with propellant. You can see there people wearing specific suits because of the dangerousness of the activity. In parallel, BSAT-4b was also filled with propellant in another building called S4. After filling, the next operation is what we call flight mating. It means that we attach the spacecraft onto its adapter. After flight mating, we can transfer the spacecraft from the payload processing facility to the building.
So we have a good info here, guide, like what happens.
For that, we use the dedicated container. MEV-2 was hoisted on top of the Silda mid-July. As you know, the particularity of the mission is that we have 2 upper passengers. So Galaxy 30 followed the same path as MEV-2 before being integrated on top of MEV-2 the same day. The upper stack being prepared, we then encapsulated the upper stack with the fairing. In parallel, BSAT-4b was also prepared for flight. It started with the flight mating of BSAT-4b onto its adapter, and then we have to transfer BSAT-4b onto the BAF building where it will meet the launcher. You can see there the hoisting operation of BSAT-4b onto the launcher. On that picture, you can also see the new vehicle equipment bay, which is a new item which will fly for this mission, and BSAT-4b was mated on that. Once both parts were prepared, we can make the integration of the composite onto the launcher. Now the upper part is complete.
Okay.
Well, thanks for talking us through that. Now, as we well know, there are lots of things we can control on a rocket launch, and they're a very, very controlled environment. But there's one thing we can't control, and that's Mother Nature. So we have a couple of weather checks, one at 20 minutes to launch and one at 10 minutes to launch. Let's go over now to Bruno Gerard, who we saw earlier in the Mission Control Center next to Luce. And Bruno, can you hear me? Great. Bruno can hear me, I think. Bruno.
Hello, Cathy. I hear you.
Great. We've had the latest 20-minute weather check, haven't we, Bruno? What's the situation?
So situation is not bad. We got the information, so we have some clouds above us, but it seems okay on the lightning's problem. Winds are correct. So for the moment, up to now, we seem to have a green. This green will be confirmed at minus 10 minutes.
And Bruno, what's the weather like at the moment in French Guiana? I believe we're coming out of the raining season, is that right?
Yes, absolutely, Cathy. We just are going outside of the rainy season and we are entering the dry season. So the weather is quite changing, evolving, but up to now, it seems very good for this evening.
Bruno, what kind of conditions could actually delay a launch?
In fact, we have many factors. First one, of course, the winds, low altitude winds, high altitude winds, but also we have, like any airplane, the conditions about lightnings. We don't like to enter big storms, so we check all the weather above the launch pad, but remember that in 2 minutes we are outside of the atmosphere.
Great. Well, thank you very much indeed, Bruno. We'll await the weather check at 10 minutes too, but for the moment, best wishes for the rest of the countdown. Thank you, Bruno. So we are flying on board Ariane 5, as we've said, the big, powerful beast of a launcher, the heavy lifter of the Ariane family. We have 3 launches that we launch here. She's going to take off in just under... She's going to take just under an hour to deliver our satellites. And so let's just have a look now at what's going to happen once she lifts off and how she's going to do that.
The booster ignition will trigger the liftoff of the launch vehicle. Shortly after the liftoff, the launcher will perform a pitch maneuver in order to get in the right direction. The booster separation will occur slightly more than 2 minutes after liftoff. Just after, we will separate the fairing as well. The main engine switches off when the intermediate orbit is reached. This event is called injection into orbit. Just after, the main stage is separated and will fall down into the Atlantic Ocean. The upper stage is ignited and it will carry our passengers up to the geostationary transfer orbit. During that flight, we have still the effect of the atmosphere, even if thin, because we fly very fast. This is the aerothermal flux. Upper stage switches off when we have reached the orbit. This is the beginning of the ballistic phase when we can separate all the spacecraft. First of all, Galaxy 30, then MEV-2 separation. Before separating the BSAT-4b, we separate the SILDA. And finally, BSAT-4b, our last passenger. The launch vehicle mission is not completed yet because it will start the passivation. After that moment, the Mission Control Center team will take over and the spacecraft team will make all the job to get the satellite up to their final journey.
Indeed, and of course, Galaxy 30 and BSAT-4b will travel on their own to their final destination, which they have their own slot in space and they'll be going to that slot. But MEV-2 is different, isn't it?
Completely different, because it will dock to another satellite, which is a customer of MEV-2 to extend its lifetime.
So it's actually going to dock with another satellite, and then it's going to push it a little bit, use its own thrusters, and raise its orbit.
All the maneuvers, yeah.
Yeah, it's really, really exciting technology. Now, we have two control centres working on the launch over in French Guiana. We've got the Mission Control Centre, which we've been looking at. But we also have another one. It's called Launch Control, and it's closer to the pad. It's about, I think, about 3 kilometres away. There it is. It's actually a concrete blockhouse, isn't it, Damien?
Yes, it is, and it is completely airtight at the end of the chronology in order to protect the people. We have there basically two teams, one which is the operational team who is responsible for the final operation before liftoff, and another one with the flight worthiness team who is in charge of checking the flight worthiness and last status of the launcher. This latest team is led by Guillaume Galato, the LSTO, whereas the operational team was led by the LCOM, Patrick Lucet, that we have seen at the beginning of the movie. And you can see there people working inside the CDL.
So that's the Launch Control Centre there in French Guiana, but there is actually another one in France, in Europe, and it's called Space Code. It's an exact replica, so all the launch controllers in Europe can see exactly what the launch controllers can see in French Guiana. Let's find out a little bit more now about how it works and the reasons for it.
Yes, now we will get to know what's the reason.
Welcome to all of you in our Space Code room in Les Mureaux, close to Paris. This is one of the rooms which is in place for each of our Ariane 5 launches, where we have operators preparing the launch during the day of the countdown, as it is the case today. When we prepare a launch, as we are doing now, we have in fact two teams which are working together. There is one team which is fully in Guyana, in the range of 50 to 60 people, who are actually operating the ground system equipment that work with the launcher, that feed the launcher with electricity, that feed the launcher with fuel, with propellant, and so on. And these are the people that activate equipment on board of the launcher. And there is a second team which is in place, and this second team is in charge of supervising the status of the launcher. This second team is in charge of checking each and every parameter on board of the launcher during the operations conducted by the other team. This second team, in fact, is divided in two parts. There is one part of that team which is now in Guyana, and a second part which is here in Les Mureaux. The first half of the team and the second half of the team are working together on the same displays. They have exactly the same setup of displays to monitor the launch. The difference between the two teams is that the people who are staying in Kourou for supervising the launcher from them, in fact, these people have more frequently a need to interact with the people operating the launcher, so the supervisors talking to the operators of the launcher. Here in Les Mureaux, the people who are here with us today are more looking at parameters of the launchers that will not require a direct intervention by the operators, but that may require a work together with a third team, which is a team of experts that are put at their disposal in another room in the CALM, and these experts will be called by the supervision team here in Les Mureaux, should there be, at any point in time in the chronology, should there be an anomaly, a singularity, something which has to be checked by technical specialists.
So hello everybody, I'm very pleased to be here with you in Les Mureaux premises. We are in a room where all the launcher technical leader will be for the chronology. We are in charge here to prepare the chronology in the space code rooms, so meaning with the preparation of an organization note where we gather all the people, the key people who are involved in this chronology. So, and during the chronology, we have also to ensure that all people are well positioned, and we have to ensure that all the communication with crew are correct. In case of a specific technical event or anomaly, of course, in the position of LSTM here in Les Mureaux, we have to alert everybody so that we can then work together and, of course, provide support to our colleagues who are also in Kourou dealing with this technical event.
So, guys, this is what we
Interesting,
have.
Huh?
Completely, yes.
Two complete replicas. So the final countdown started about 11 hours ago. We're now 8 minutes and 37 seconds to launch, getting towards the end of that final countdown. What's been happening?
The teams have been completed the operation since this morning. Mainly the operation were checking the electrical connection between the different elements, flushing and cooling the feeding lines so that we can fill the tanks with propellant, activating the equipment on board the launcher, one after the other, to check the status. And we are doing this in order to be able to check that everything is working perfectly before we enter the synchronized sequence.
And here we can see the teams in...
Guys, if you like the stream, you can give it a thumbs up and subscribe, because this channel covers all the launches of all space industries. So you don't have to search for other channels. You can just rely on this channel. So yeah, you can hit the subscribe button and the like button.
The status panels, and this is the range operations manager.
Yes. The range operation manager is the one that is coordinating all the activities on the basis and which receives all the information from different elements.
And he's the one who's going to be calling out all the important milestones, because, of course, there are lots of buildings across the base. Yes. And everybody has to listen to the range operations manager.
And guys, one you can say interesting fact is that this launch control room is basically shielded with any sound coming out of this room. So whatever media briefing or whatever public briefing that is done behind the walls. Those glasses which you are seeing behind them, those are soundproof glasses. They can't be used by they cannot transfer the sound. So yeah, that's one interesting fact. So they don't lose any concentration. Thanks for subscribing, Oliver.
Aren't they, Damien? What's
yes,
happening?
The synchronized sequence is a sequence which is fully automatized, which performs the latest preparation operation of the launcher and of the ground, and the launcher is taken progressively autonomous, independent from the ground.
We can see in the Mission Control Center those boards that you're looking at on the left-hand side, the green panels. We call those the status panels, and all the systems across the base are sending their status there.
Yes, we have a panel which is made of all elements that are green up to now. These elements correspond to subsystems which send their status. So mainly we need the launcher, which will send its status. We need a go also from the customers, which will send their status. And finally, the launch base. Everything is like a traffic light. If it's green, it's a go. If it's red, we have to stop, investigate.
Exactly, or it's a little bit like the dashboard of a car, same thing. Now, we are now joined by Raphael Chevrier as well, who has come to see us here in the studio. Raphael, thank you very much indeed for being with us. You tell us your job and what you do, Raphael, for Arianespace.
Basically, I'm a business developer. So with my colleagues, we are working on new innovative mission concepts that we can address with our next generation of launch vehicle, Ariane 6 and Vega C, in the context of a very fast-changing satellite market.
And it is changing extremely fast, isn't it? Because, of course, everybody's, well, certainly, I think probably in March I had never heard of Zoom, and now I use the word like Google. Let's Google something and we Zoom it in English. I don't know whether in French you do the same thing. So things are changing. We all want more internet.
Yeah, there is Zoom, there is WebEx, so there is a real big demand in this dramatic situation of connectivity for situations of remote working. And so we know, and it confirms that the satellite have like a role to play in this communication, providing through large projects of constellations, internet signals in order to connect everybody anywhere.
And right now we've got some very important satellites up there inside the fairing, which are going to help us to do that and make those connections. What are the conditions like inside the fairing? I'm guessing that they're kind of like first class in an aeroplane,
yes, we can
air conditioning and that sort of thing.
The fairing here protects the satellite from the outside environment, we can say. First, we monitor the temperature inside the cavity, and we also check the conditions in terms of humidity and cleanliness for it to be perfect before liftoff.
So right now they've got their seatbelts on.
And everything is ready for
waiting
liftoff.
for liftoff.
Cross fingers.
Yeah. And the cabin crew are doing the final checks. So we have a number of things.
Guys, we are only T-minus 3 minutes and 20 seconds left.
22 seconds.
So that, oh, okay, that was synced.
Take a look at our launcher on the pad.
So now we should have a look at the launch pad, and we will be able to see the
reasonably clear. Earlier
rocket
it was looking
itself.
a little bit cloudy, but actually the clouds seem to be parting. It's 6
Thanks
o'clock
for
coming up to 6
subscribing,
o'clock in the-
Christopher.
It's coming up to 6:30
Appreciate
in the
that.
evening there in French Guiana. Just remind you that French Guiana is on the Amazon, in the Amazon rainforest.
Yes.
What kind
it
of
is close to
temperatures?
the equator, so we have a specific weather there.
Okay.
I'm guessing, Raphael, right now is the time when the mosquitoes come out over there.
Yeah, I have not spent so much time in French Guiana, but yeah, it's quite strong situations.
Exactly,
weather
Cliff.
conditions.
The
Yeah,
space
but we are very
is
lucky
for
because we are
everyone.
not experiencing, and it's very important for launches.
Guys, hit the like button if you haven't till
leaders
now,
and this
and
kind
just
of,
wait for this
weather
beautiful
condition
launch
can
to
be
happen.
game changer for
The launch will be spectacular. As you can see right now, the
Getting
views
closer
are
now, coming up to 2
spectacular.
minutes to launch. Let's talk about some of the activities that we see before a launch. We will count to 7 once we see the ignition. And before we talk about that, look, we're seeing here the cryogenic arms. The cryogenic arms are feeding liquid hydrogen and oxygen into the vehicle. What kind of temperatures are we talking about? Very cold.
The temperature are really cold because for the liquid hydrogen, the temperature is minus 253 degrees, whereas for the liquid oxygen, it's a bit warmer.
Suite à un rouge ensemble de lancement. Que tous les moyens restent prêts pour la reprise de la chronologie à 0-7 minutes en cas de retour au vert.
So
Okay,
that's
so
what the
we've just
mission
heard from the
control.
range operations manager that we'll translate that, and Damien will translate that for us. But we have a red status panel. As you remember, Damien was just explaining to us that the traffic lights are red for stop, green for go. We have a red status panel. That means that we need to stop. Damien, just to talk us through what the range operations manager just said.
This red corresponds to a red coming from the launch base. However, everybody is still keeping ready in order to restart the activities when the issue will be solved. This situation is completely nominal because the aim of this kind of check is to check everything before we go for liftoff. So we are currently treating this anomaly, and we will come back when we will have more information about that.
So the chronology is continuing for the moment, the chronology, or what we call in English the countdown. And as you say, Damien, the system is absolutely made for this. So red status panel is a perfectly normal thing to happen because it's flagging up a glitch that we need to fix. And once we can get that sorted out, then hopefully we'll be able to launch. Now, we have the status panels. Let's just see whether we can have another closer look at our status panels so that we can have a look and see the red status panel that has turned red. Yeah, no, maybe we can't see that right now, but I'm sure we will in just 1 second. So we have a launch window tonight, quite a comfortable launch window. For anyone who's unfamiliar with a launch window is the time during which we can launch. So our time was roughly 11:30 for launch
So guys,
tonight.
right now one thing has happened. Let me just tell you that the panels which you are seeing, one has turned red, and those are basically the checks which the rocket has to perform so as to enable it for launch, and one of them has turned red. So right now we are in hold, and we right now don't know the reason for it, but yeah, we are right now in hold. That panel is also has you can see the French written on it, so I can't even tell you what has
putting all
gone
these
wrong.
constraints together in order to build what we call the launch window, which is the time during which we fulfill all the constraints for the customer from the launch base and from the launcher. And for today, it's more than 40 minutes.
Yes, guys, they are launching, and thank you for subscribing, guys, and yeah, hit the like button if you haven't right now.
What's everybody doing now? Because as you remember, we've got the several different control centers. We've got the Mission Control Center, which we've been looking at, the nerve center, really, where Luce and Bruno are sitting and the other teams. We also saw the Launch Control Center, where the teams are concerned primarily with the launch vehicle and the launch pad. What's everybody doing now in a situation like this?
It's depending on the issue that is being treated, of course, but all the teams that are involved in the technical field covered by the issue or the points to be resolved is working currently on the topic with the help of all technical teams which are located in Europe or directly in French Guiana in order to help solving the issue as quick as possible. And one other important point for this mission is we spoke about the launch window, but we have quite a kind of particularity for this mission because the launch window is split into two sub-launch windows because we check, of course, all constraints, as I told you, and one of the constraints that we have to check is that we have no risk of collision with the ISS, which is a really important
Yes, so
criteria.
let's just talk about that in a little bit more detail. Maybe you could explain to us what the ISS actually is, the International Space Station.
Space Station is like one of the major projects that's been built in space, and it actually is a good example of cooperation in space because there are lots of space agencies, national agencies that are implicated there. And of course, you know that our national hero, Thomas Pesquet, went there once, and he will go back there.
I'm just going to remind everybody that Thomas Pesquet is the French astronaut who lifted off to the International Space Station 2 years ago?
About 2 years ago.
About 2 years ago.
Yeah.
And just a quick interlude, because I was actually doing the commentary during that launch, and it was a very wonderful moment when Thomas Pesquet opened the hatch and flew into the space station, because I was in the Mission Control Center in Moscow, and Thomas's mother was in the control center, and of course, understandably, she wept, and I think we all wanted to weep because she felt so proud of her son floating into the space station. So that was a very, very wonderful moment. But yes, just continue what you were saying.
Yeah, and right there, basically, we are testing a lot of things, technologies in space. I want to remind that the International Space Station is within the area where the magnetic field of the Earth is still protecting astronauts from radiations from space. So it's quite like a safe place to work there. And so you can test technologies, you can run very complex experiments, and especially experiment in zero gravity conditions.
Guys, I think what she is being referred to as the rocket itself.
Growing more and more with the time. And so, yeah, there are lots of stuff that are happening
Thanks for
there.
Subscribing,
and the International Space Station
was.
Is going to be
Really
running
that.
for a few more years. And then the national agencies are right now thinking of a new way to continue this kind of cooperation. And the main idea right now for them is to actually do an International Space Station around the moon. So the challenges are much more strong.
And that is what we are calling a gateway.
field of the Earth to protect the astronauts.
Exactly.
So you have to test strong technologies to protect from the radiations from space, etc. It's like 380,000 kilometers from Earth, the Moon. So it's a much longer way to go
So
there.
guys,
So
let me
it's,
just tell you
very,
what they are
very
talking
exciting,
about right
space
now.
detail
Basically,
that's
NASA is
It's
again
huge,
going
isn't it?
back
It's
to the moon
absolutely
itself
remarkable,
with its
and
Artemis mission,
you
and
guys are
one
involved
of
in it.
its launch is
It is
scheduled
very
for
exciting.
2021.
Now,
And
we're
right
going
now,
to,
he was
I
talking
think we're
about the
going to take
gateway.
a break.
Gateway will be like the
Countdown
International
is
Space
on
Station,
hold.
but around
As
the
we've said,
moon,
we
and
have a
that will
launch
provide
window, so we're
every
going to
docking and undocking
wait now
services.
and
Basically, the
I'm afraid just
launching
for a
and
while get a little bit
delivering
more
of
information,
payloads
and we'll
and
come back
other
to you. In the
services
meantime,
to the moon.
do
Gateway will
keep your
serve
eye
one
on the
refueling, or
website
you can say a checkpoint
arianespace.com, and we'll come
to
back to you when we
from the
have more
Earth to the
information.
moon.
But for now,
So yeah,
see you shortly.
that is what they were talking about. And yeah, of course, since when we are closer to the Earth's magnetic field protects us from the solar winds and solar radiation. But when we are farther from the Earth and we are on the moon, uh, in the orbit of the moon, then we have something some problems itself, because then we aren't protected by the magnetic field of the Earth, and the moon's magnetic field is very weak to provide any of the uh, protection from the solar winds. So yeah, that's what it is. So right now we are in a hold, guys. Something has happened. The one of the red panel appeared, and they are right now checking what has happened. And once we are there again, then we will be able to launch. And I think we have a launch window, and that's launch window. We do have some time which we can rely upon. Launch on hold, and yeah, we have a 45 minutes launch window. So if we have you can say they can correct the issue in the 45 minutes, then we will be able to see the launch. That's the thing. So yeah, it will be launching today. So Louis Carter, you have your nephew today. So hi Taylor Carter, shout out to you. And so Paul, see what's on the drawing board and what's not in there. Basically, reusability is being thought by every space agency in this world right now. Okay, unless if it is a new space agency, that's another thing. But reusability on drawing boards is everywhere. I can confirm that. But the only thing is how interested the, you can say, the whole agency is for developing that technology. Like is there, do we have a political thing backing up that plan? Because that political thing backing up that plan is very very necessary, because they only will provide the funding and all. And if they can if they are interested in that, then they will obviously the team will also do that. But ESA, if I'm not wrong, ESA is more of a scientific research space agency, and they don't focus more on launches, and that's why they don't provide they don't have their own, you can say, rockets as ESA and all. They have Arianespace, and that rocket launch is all that comes under Arianespace. So yeah, that's the thing. So hi Stacy, Sim, and shout out to Freddy. Shout out to Freddy Collis, if I'm not wrong. And okay, no problem. We everyone is family here. We are the space tubers here, guys. Everyone watching right now, and yeah. Since what do you want, guys? Should I replicate this mission in Kerbal right now? Because I think so. It is in hold. Or you want me to talk about something else? You can just type in the your questions, and I'll be able to answer. If I have the knowledge, I'll definitely answer that. So yeah, you can just type in the chat. So we had some issue with the launch right now, and yeah, that's the thing which we that's why we are at halt right now. Wait, but let me just confirm from the what are the updates. If we had any updates, then we would have it right now on the screen only. What are the four towers around the rocket? Okay, so the four towers are basically there for the communication and for providing electricity. Basically they are for providing electricity only. Protection from lighting, yes, those things for the red thing which you are seeing, that is also a thing. Thanks Tommy Slav for answering that. They because these rockets are all metallic, right? And whenever something, if uh, if that happens, if lightning happens on the launch pad, we don't want the lightning to go through the rocket. So and where does the lightning go be means what path it takes depends on the resistance of the material. Lowest the resistance, higher is the permeability, you can say, of the current. So the resistance of the metal is very low, so always and always the current wants to pass through that. So that's why these, as you can see, those electrical towers, those towers are longer than the rocket. That is needed because whenever if there is any lighting, uh, the lighting will hit those towers first, and then it will ground itself, and the launcher will be there uh, at a safe location and will be healthy. So yeah, that. And one more thing, one more interesting thing which I got from this, guys. uh, I remember one thing. Okay, just tell me, guys. I'll ask you one question and tell me what will happen. Okay, so it's a Q&A kind of a thing. So guys, you I'll give you a situation and tell me what will you do. Okay, so you are stuck in a storm and heavy lightning and thunderstorm is happening. Okay, now you have two options. One, okay, we have three options. One, you can just go outside, and you have to go outside your home because your home is like on fire. Okay, so now we have three options to go outside. Either you just go naked without anything, without putting on anything, you have that option. Second option, you put on the rubber suit which is there. To basically, that is whatever options I am giving will depend on the lightning condition, means there is a thunderstorm, so choose wisely according to that. Okay, so one is the you can go naked, second is the rubber suit, and the third we have a metal suit. So which from those three options will protect you from the lightning? So tell me that. We have a option to go naked. Second, we can have a rubber suit which we can wear, and then we have a metal suit. So what will be there? Just type in the chat, guys, if you want the. I'll do the, yeah, High River Racer. I'll do the Kerbal, but let's okay. Let me just load that in the background itself, and oh, wait a sec. Yeah. So yeah, guys, answer. Harsh says rubber suit. Fergus says metal, and once we have metal suit, rubber. Okay, naked because it is more fun. Okay, Jason. Okay, and yeah. So guys, if you have all your answers, then uh, I can give the answer, basically the what's the correct answer if you have done everything. So guys, let me repeat the question. You are in a situation where your house is on fire and outside you have thunderstorm, and you have three options to go outside. One, you can go naked. Second, you have a rubber suit, and third, you have a metal suit which will protect you from the lightning. Okay, Mark, that's a good thing. So let me just give you the answer itself. So the thing which will protect you from lightning, it's the answer is very interesting. It's a metal suit. It's a metal suit. So uh, whosoever gave the Fergus gave the answer metal suit. Yeah, that's what was correct. Basically, the reason is the same. Why it will happen, I'll tell you. First of all, if you go, uh, first of all, let's just have a situation for option one. If we go naked, if we just go naked, then the lightning will hit us. So that's not we that's not anything. We don't have any protection, so of course the lightning will hit us if we are on that range, you can say. The second option was the rubber suit. Okay, so rubber suit, you as you know, the rubber is not a very good conductor of electricity. So what will happen, guys? uh, our body is you can say a good conductor rather than the rubber suit. So what will happen if the lightning falls on us and we are in a rubber suit, then the rubber suit will explode because of all that high charge and high voltage and all that. It will explode and you will die. So rubber suit is not a good idea. The third one was the metal suit. So how it will protect? The reason is same which I gave for the towers. Once you are in the you have won the metal suit. So if the lightning hits you, then also you are safe. Why? Because the metal suit is a conductor, right? So all the lightning and the charge and the electric current will flow through those conductor and won't touch you, because the conductor, the lightning, or the current always takes the least resistance path. So yeah, since the metal has the least resistance than us, so that's why it will go through the metal to the ground and we will be safe. So yeah, 3 Sanket. Oh yes, yeah, you also said it right. Okay, so yeah, that's what the thing is.
Rouge sauvegarde.
Okay, we have something from the mission control. So I didn't ignore anyone, so it was just missed. The chat just missed. So yeah, that's the thing. So yeah, that was one interesting thing to have, right, guys? And the Kerbal is loading right now, and we do have an Ariane rocket there ready. I have that ready, so we can have the. So yeah, that's one interesting fact. So let's just load the thing. Come on, find it. Okay, wait a sec. Let me just. The hell? Why is it not capturing this? (6:16 p.m. EDT) world today. Okay, thanks for your update. Let me just see if we can have that. Is it correct or not? Let me just confirm it once, guys.